Welcome everybody to this afternoon session, which was actually initiated in Chicago a few weeks ago when I met with the friendly guys and girls from 3D Natives, and we had a discussion about the coming up micro launcher industry, particularly with a view onto Europe, and we thought it might be nice for a few minutes, 20 minutes workshop to give you a little bit food for thought, as the Americans say, on what's going on over here in Europe and why it might make sense to see that as a little bit independent development from the traditional 3 or 4 aerospace launching countries like USA, Russia, of course, with all the problems we know, China and India. And let me try to share my screen. So we can start with that. Just trying to find my slides, which should be here. And this is it. And we go to the presentation mode. And I hope everyone can see the slides. Otherwise, please, someone give me a hint. Yeah, micro launch is on the rise in Europe, and what I mean to speak about is particularly in Germany, where I live. Speaking to you from Hamburg in the afternoon here today, is we have the situation that the traditional rocket manufacturers and launching companies have worked with big rockets, which heavy load satellites, and we see programs coming up now where a multitude of thousands of telecommunication satellites, a lot of them in very small scale, cube size 10 by 10 by 10, are used for this type of communication, and that will enable much more inexpensive rockets to be used to launch those satellites, resulting in a much higher quantity of launches, which then gives secondary problems to where do we place the launch, what is the traffic on these available launch pads, and that leads to new questions. Australia wants to have own launch pads, Germany and Norway are discussing about new launch pads at the moment. And there is various interesting projects coming with this. Of course, we cannot go into detail within these 20 minutes, but I will try to play a video with the next slide, which should tell you quite significantly how this is tackled at the moment in Germany. And I hope it now starts to play, and you will hear the sound. Okay. I'm just hearing the sound of the video is not working, so I might give a few further comments to that. So you do have, exactly, well, you do have, fortunately, the writing for the voiceover, but as you can see from the video, there is 3 main new companies coming up in Germany at the moment, and all 3 will head for quite a significant government funding. Well, there you go, 100 million euros for ADDITIV Aerospace is quite a lot for us.
Okay, well, we'll just get that sorted. It wouldn't be a virtual event if there weren't the occasional little hiccups. Someone will just be in contact. There you go. There he is. Are you with us, Stefan?
Yes, I am.
Perfect. Well, I'll leave you to it then.
Yeah, they're very good. No, we're all here. This will be over in a minute or so. No worries there.
I don't think you're sharing your video, by the way.
Oh, the video is not showing. Oh, what happened there?
No.
No. Do you see the next slide now?
No, I think it's not sharing. If you could just try that.
Okay, we just retry. We just retry then for whatever funny reason. Share the screen again. Share the screen, best for high motion videos. Well, we'll try that. So, and choose window, choose this, share. Do people see that now? Yeah?
Yes.
So I will then skip. I will not change to the presentation mode. Maybe that's the problem in this remote, and it's a PowerPoint. Well, whatever. We should use that. So what was shown, the video, for those who might want to watch that later on, is the German GTAI. It's the German Trade and Invest being part of a government of Germany, economical ministry, and you find that video under YouTube, so you can play it later then as well. Sorry for the mishap with this IT problem. So what I wanted and why I wanted to show the video is what it shows is for a European hemisphere, which was not used to have independent work into outer space rocket other than the Ariane joint program. This new space area brings up so many independent new companies which seem to be small, with just a few 10 or 100 or so workers in the individual company. However, it is looking for a multi-billion-dollar market in the near future and the coming years, and this will propel the directly associated space corporations, but also additive manufacturing, because the problem that will arise with having so many launches will be the necessary production of highly complicated part of the rocket equipment, like rocket engines, which then will require or need additive manufacturing to be a technology coming into this. To be able to sort of mass produce these components for the rockets in a lightweight and smart bionic way in very short time, because a traditional standard rocket engine takes many weeks, if not many months, to be totally produced at the moment, and that would not enable such amount of launches. The slide you see now is one of the smaller and very interesting companies, in case you wouldn't know them. It's called Copenhagen Suborbitals, from Denmark, from Copenhagen, of course, as it says. And the particular reason why I highlighted this in this short presentation is they are all voluntarily people who have another job for their daily life and do this in their free time. However, they are serious rocket scientist people. It's not just somebody who has a crazy idea, but what they want to try is not to go for the very high end of every material, but they are trying to build capable rockets out of everyday's materials and manufacturing technologies to make the whole process to use a rocket quite inexpensive. And it's a bit slow because it's voluntarily and they're depending on donations, but they have already launched various rockets, and their next project is to bring a human into the orbit and back with the next big rocket project. And I always can only recommend very much to go to that website and have a look at it. And if you're thrilled by it, maybe also donate for them, because that is an initiative which is not the mainstream of the big government initiatives. And this is why I'd like to put it into this as a counterpart and counterforce. And of course, using 3D printing will help them as well. And that, well, discussions are going on in various kinds, let's put it that way. And to support, I jump a slide, why so many launcher vehicles will be needed. Just two of many different companies which are competing in this. Well, it says that 59,000 satellites by all different countries and companies will probably be launched by 2029 globally. And just two major projects is, of course, the SpaceX Starlink program, which, according to what I found, has a number of 2,000 plus live satellites already up there, and has a license to bring up to 12,000 satellites at this moment, and has applied for a further 30,000 satellites. Well, this is not one launch per satellite. This is 40 to 70 satellites in one launch of the smaller ones. And the second one that made quite a big noise in Germany and Europe, like 2.5 weeks ago, is that Amazon was bringing a similar program called Kuiper, with 83 launches on 3 platforms that have been booked for up to 1,500 satellites. And 18 of these launches are booked with the new coming Ariane 6 rocket. That's not a small micro launcher, but it's a big rocket. But that will bring definitely billions of euros into the European space industry and will make that a significant and independent part of the global space industry here. And where do we get into additive manufacturing and can enhance additive manufacturing? On one hand, it will be, say, an increased and enhanced use of additive. The cube satellite housing, which could be carbon fiber, plastics, or plastics only, or a mix of metal and plastics, is one example. Here is a picture from ESA. There is those of you who came to Formnext show in November in Frankfurt all could see the AMCM rocket engine housing they were building. That is an 80 to 90 centimeter high part, very high part. They were building in the US on a special modified EOS machine there, which looks to the future of faster build up of more rocket engine parts. And of course, quite a new one that just made part of the press 2-3 weeks ago. On the left, you see one of the Fraunhofer institutes in Germany. Professor Schlick is part of the team there. It was published on LinkedIn recently. That is a new research they do on doing multi-material printing in one machine, in one go, which gives a combination of individual metals. I think here it's titanium and copper, if I remember it right, which again will bring the whole design of rocket engines to a more to the next level. I'll say more performance, and that's what I was looking for, and the next level. And if you then combine that with tailor-made and tailor-designed alloys, which are coming a lot, whether it would be mixing various metal alloys on demand, or it would be like the Glitcop, the mixing of ceramics and copper, for example, or we have zirconium titanium alloys that are coming up now and are also able to be used in metal as well as sintering, plastic and other additive manufacturing processes. This is the road we're following in this industry, and this is where this all will go, and not in 10 to 15 years, but in the next 2 to 5 years. We'll all see that in everyday's production. And as I look at the time, and it's already only 3 minutes to go in the time I was given, I think I should switch back from end my presentation sharing and come back to you, and I hope you could see at least the slides. It's always a little bit tricky with Remo sometimes, and I'm not sure we have time for additional questions as it's only 2 more minutes, but let me say, so far I'm in engineering for 38 years. I was a kid when the moon landing was happening, and now we see in every country every day's possibility of launching satellites into orbit or do even more. I must say, what a fulfilling cycle in an engineer's life, which, well, hopefully and obviously is not over already. And this is the vision and the motivation I wanted to bring to you in this very short workshop. And obviously you find me on LinkedIn or somewhere else on the internet, and happy to discuss that further with you, also offline, as I think by now the time is over. I might not be able to participate in the later get-together sessions today, because unfortunately it's still work day in Germany and I have a few more meetings coming up. But I hope you did enjoy this fast rush through, and happy to discuss that in more detail. I'll be personally available in Detroit for the Rapid Show in 2 weeks from now, in case some of the American people will come there. Happy to meet in person for a drink or two. Thank you very much.
Well, thank you very much, Stefan. It was great having you.